Hey everybody, Lars here. I know this must be weird because we haven't met yet. It's one of those instances, sometimes with this class being a hybrid format, we will meet on the first day of the semester, and sometimes we will not meet on the first day of the semester. In this case, oddly enough, we are not going to meet until Unit 1 is almost over. So, oddly enough, this is the first time you're going to see me, but we're going to meet very soon and be able to go through some of this stuff in person. But for the time being, this is one of, I think, 3 review videos I'm going to get you for this particular unit. I'm going to review the first half of the slides now. Then in the second video, I'm going to review the second half of the slides. And then a special third video I just quick whip up a program. I think in the past I've done like a change program where you give the program a whole bunch of pennies and you see how many dollars you have, how many nickels, how many dimes, whatever. But for now, we're just getting started out. I'm going to go through some of the basics, some of the simple things about starting up with Python, doing your first Hello World program. Then we're going to take a look at some arithmetic operations and doing some arithmetic. And then we'll finish up by looking at the input statement and getting the user to bring some stuff in. All right? As always, if you have any questions, please put them in the forums. If you can see under the forums, and a lot of you obviously already know how to get around in Sakai because you're already putting in your introductions, which is fantastic. I always put a Q&A section up for whatever we're doing that week. So if you have any questions, please go there, ask, send me email. I'm a night owl. You send me email at 2 a.m., I'm likely to answer it. You send me email at 8 a.m., not so much. You'll get the gist of it as the semester goes on. And we're going to meet each other soon anyway, right? Tuesday the 31st, so that's coming up. First thing I want to do is get Python going. And I know Python is one of those things where if you went there to python.org and downloaded the latest and the greatest, I think the latest and the greatest came out December 23rd, right, a couple days before Christmas. And that's version 3.6. You see here on your screen, I'm using 3.4 still. 3.5 is fine. I say use 3.5 if you can. And I know I think I wrote that somewhere in the slides, I believe. The reason I say is because we're down the line going to use some third-party libraries. One called NumPy, one called SciPy, definitely one called Matplotlib, where we do graphs and a whole bunch of other things. And I don't know if those third-party libraries, the people who maintain that software, are going to be up to speed enough to make sure their packages run with 3.6. So if you go with the penultimate, the version before, the latest and the greatest, you know you're pretty good when it comes to libraries. When I first started teaching this course 2 years ago, I was using 3.4, and I would tell people to avoid 3.5, but now we've gotten to the point where 3.5 is mature enough that all of the major Python libraries, and you'll know what I'm talking about after a while. I know Python is very rich in kooky jargon and things that relate to Python. I am going to enculturate you, and at the end of the day, you will be a Pythonista. Python programmers are weird and special and a whole bunch of different things, and you'll see if you have any experience with other programming languages what I'm talking about later. Python does things a little bit different, a little bit skewed, and you'll figure that out as we go forward, okay? So if you can, load 3.5. I usually at first, we use idle as the IDE, so if you just go get straight Python and use idle as the IDE, that's fine. If you want to go get IPython and use it, great. I got no problems with it. I mean, if you're looking at my screen, you can see I have IPython right there. Okay, you want to go get Anaconda? I was going to say, you see the Spider IDE right there. I have Anaconda, too. I love Anaconda. But I don't use it when I teach the course because I want you to concentrate on the language and not the tools that go along with the language, blah, blah, blah. But later on down the road, we'll say a little something about Anaconda and using the Spider IDE. We'll say a little bit about IPython. You know, we may even talk about Jupyter and notebooks and things like that. But right now, before we get to all the bells and whistles and the niceties, we got to worry about some Python. So I fired up idle, and I've got Python 3.4 because it doesn't matter. My 3.5, I think, came with Anaconda, and I haven't even gotten a 3.6 yet. I mean, thing's not even a month old yet. So, by law, programmers are duty bound to start with hello world. So I'm just going to print hello world to the screen. This is the Python interactive window. When you first start it up, you see that prompt, and you can begin giving the interpreter, the Python interpreter, commands. So the first thing we're going to do is I'm just going to give Python a value. I'm going to take the variable a and set it equal to 4. And then if I hit a, it prints out 4 for me. Pretty snazzy. I can do it with another variable. I can call it b. I'll make it 11. And then I'll say b. Again, pretty snazzy. I can say a plus b. And it tells me 15, which is correct. Pretty snazzy. All right. I can also set the results of that to another variable and show that variable. So now I have a, b, and c. Okay. That's how we set variables. Basically, we give a variable name and we assign it, not equals. I know you're going to see this and you're going to think it's an equal sign. It's not. In computer programming, when you only have one, a lot of languages, C, Java, some other ones, it's not equality. It means assignment. So we're assigning something to that variable name. And you'll see as you read the slides, variable names have certain rules. You don't want to start them with symbols. You don't want to use keywords, which are words that the language needs and uses, because then things will all go haywire with your programs. But we're not going to do that. So we're just doing this in the interactive window. We haven't even done a program yet. We're going to do our Hello World program in a second. But first I wanted to show you some simple stuff with variables like I just showed you. And we are not limited to just whole numbers or integers. We can also do floating point numbers with decimal points. We can also do what computer scientists call strings or sequences of characters. Okay? We have a simple command / function. It's really a function that allow us to examine our variables and tell us what they are. That says class int because a is an integer. I can do type D and see that D is a floating point value because it has that decimal point. Okay. If I do a type for W, I will say str for string because that's a string. It's a sequence of characters. Okay. So Python lets us set variables right here out at the command window. You'll see the interactive command window is basically where your output's going to go, your output from your programs. Another thing that becomes useful is when you run your programs, the interactive window has access to that memory area. So we can come here and debug and see what our variables are after we run programs, and it's really pretty helpful. Python does something called dynamic typing, where we don't tell the program ahead of time what kind of variables we're going to use, strings, integers, floats. Later on you'll see booleans. We just do it. We just say, you know what, I want my variable, and I want my variable equal to 67. Boom, done. Then Python says, oh, you know what, I've seen 67 before, and it doesn't have a decimal, and it's probably a number and not a string, so I'm going to make it an integer, and that's what it does without us telling it. Okay? Enough of this. I digress. Let's go ahead and do our first program. When you are in the here, I'll zots it out. I'm assuming that you put somehow you got an icon for your idle up there. If you didn't, hold on, don't let me mess with that Camtasia because that's what we're recording with. This is I'm probably opening up a can of worms with this, but because I know a lot of people are using Windows 10, and Windows 10 sticks things in that user directory, and it's all confused. I'm still running Windows 8.1 because I didn't see any reason to upgrade. So I created a directory called Python 3.4, which is where I dumped all my stuff. When you can find your root Python directory, go to the capital LIB directory, and then down there you'll see one called idlelib. Go to idlelib, and then down here you'll find your idle. Okay? Python, whatever your Python directory is, lib, idlelib, and then you'll find idle. Idle is written in Python, so we're creating programs in a program that's actually written in Python. Okay? So idle is right there. If you take that, drag it to the desktop, that's if you're Windows. If you're Mac or you're Linux, there's other things to do. And then you'll have an icon for Python. So if I double-click that and we start from scratch, let's say I want to start a program. I want to write a program from scratch. So what I'm going to do is I'm just going to say File. I'm going to say New File. And it's going to give me a new window. Look at that. How wonderful. And now the first new thing I'm going to teach you, don't want to do that, is I want some comments. Okay, I want to tell people what I'm doing while I'm doing it. So the first thing I'm going to do is I'm going to say author Lars, because that's me. And then I'm going to say a simple program for hello world and arithmetic, because we're going to do some arithmetic after I say hello world. Okay, good enough. Then what am I going to do? First thing I'm going to do is I'm going to do my command with the print function and say hello world. Okay, do the exclamation point. And now I want to run this program. So what do I have to do? First thing I'm going to do is I'm going to save this program to my hard drive. And I can do that very easily by just saying save or save as. And I'm going to run to, I don't know if I set it up yet. I may not have. Look at that. Spring to the, look at that. Unit 1. I'm going to call this Rev 1. And I don't have to call it pi because it's going to save it as pi. As you can see, save as type. So I'm just call it Rev 1. And boom. So I saved it, as you're going to see, and as you're going to see me do later. Later, I'm going to make changes, and the program's automatically going to run. What I'm really doing is I'm just hitting Control-S to save, okay? And then, as we can see, in order to run our program, come over here to Run, and you click Run Module, okay? And it runs, yay, and you see Hello World, okay? Your output from your programs is going to be over here in your Python Interactive window. But later, you're not going to see me do anything, and you're just going to see it run. That's me just hitting Control-S F5. When you're a Python programmer, believe me, you'll learn how to do that fast. You do it in your sleep. Okay? So you'll make a change to the program, blah, 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 then you'll just do that, and everything will run for you. Okay? Let's do some math. Let's see. Let's get two variables. I will call one called num1. I'll make it equal to 5. Let's grab another called num2. I'm going to make that guy equal to, let's say, 10. Okay? And then I will say my sum. We will not call it sum. Call it my sum, because sum is a keyword. Sum is a function that does something we will learn about later. And then I will say num1 plus num2. Beauty. Then I will say my diff. And we will do num1. Am I scared of negatives? I don't think I am scared of negatives. And we will do that. We will say my product equals num1 times num2. I know you're thinking of fast forwarding through this. Don't. My div is equal to num1 slash num2. You ready for this? My other div. Why not? Num1, 2 slashes. Num2. Are we going to change that? We may go change that to make it work a little bit differently, but for now we'll leave it that way. Okay? Actually, let's run this now. I can show you some other stuff in a second. We'll do my sum, my diff, comma, my product, my div, my other div. All right, is that going to print all the variables? As you can see, I'm not explaining everything as I go along. I have set up two variables. We evaluate our equations from right to left. So I'm taking 5 and I'm assigning it, not equals. 5 is being assigned to the variable num1. 10 is being assigned to the variable num2. And then I am using them arithmetically and creating new variables. I have a variable here called my sum, my diff, my prod, my div, and you get the gist of that. Then down here, using the print function, same way I use the print function up here, only here I use something called a string literal. I didn't bother with a variable. I just said, you know what, this is what I want my string to be. Print this. And I did it. So it's called a string literal. But here I'm going to print out all of the variables we created. All right? So, see up here, that little star? That means there's been changes made and we haven't saved. Look at it disappear as I hit my Control-S. Control-S, F5. What do we get? All right. We still got that hello world. All right. I'm going to teach you a little something. You see that hello world? Oh, I don't want to do that. I don't want to erase it because I might want to go back and do it again. I'm just going to put a number sign in front of it and comment it out. That's what programmers call commenting it out. So that way it won't run when we run the program again. All right? And I will prove it to you by running the program again. All right, let's take a look at what we got. My sum, num1, num2, 15. Yes, sir. The difference, -5. Yes, sir. The product, 50. Yes. The division, yes. But look at that. The first division is 0.5. And the second division is 0. Let me try to show that in a little better way. That's a good one. All right, look at that. Okay, now look at the division. 23 divided by 10, 2.3. Pretty snazzy, right? That's division last time I checked. But look when we do it with 2 slashes. You only get the 2. Basically, what this is called is integer division, or it used to be called ceiling division. So the other division, if we're dealing with integers and we know we want whole numbers, you would do 2 slashes, and you'd get the integer division. Okay? That way you don't have to round up, and we'll show you later how there's different ways to round up, and later on you'll be able to format your output and do some stuff like that. But for right now, I just wanted to show you that there's really 2 different divisions. And you're probably thinking after seeing what we did before, hey, that 2.3, that's a floating point number. Yes, it absolutely is. If I did a type on my div, it would be a float. And if I did a type on my other div, it would be an integer. That's the magic of Python and its dynamic typing working. So you don't have to worry about stuff like that. If you produce, truth be told, if you use that division and it was even, say it was 30 divided by 10, you'd still get a floating point number because it's regular division. Okay? All right, there's 2 more things I want to do, because I'm crazy that way. I want to show you, that's actually a good one for that. I'll show you my exponent first, and it's equal to num1, boom, boom, which makes sense. And I'll do num2. Yeah, I'll do num2, whatever. 2 asterisks or stars or whatever's above the 8 is exponentiation. Okay? So num1 will be raised to the power of num2. So 23 will be raised to the power of 10. So that would be an interesting number. Which kind of makes sense if you think about it, because what is multiplication? It's addition on steroids. What is exponentiation? It's multiplication on steroids. Think about it. So 2 asterisks is really, multiplication doubled. So if you think about it that way, it kind of makes sense and it's easy to remember. Let me throw this at the end of my array of thingamajobbers here. Yep, that's a big boy. Okay? So that's how you do exponents. Now the next one is cool, and you're going to like this, and remember it because it's going to come in handy. I'm going to show you modulus. Some of you probably know what modulus is already. Modulus is magical, and you're going to use it a lot. I know for a fact you're going to use it in a couple of homework assignments that we do, because it is very helpful as far as finding out if something is a factor of something else. But what is modulus? Modulus, for our purposes, and I'm sure it has some kooky Latin derivation or means whatever, blah, blah, blah. But if we wanted to understand it, we would call it the remainder operation, because that's what it is. It just gives you the remainder of a division operation. So that right there, num1 divided by num2 is 2.3, okay? But what's left over? 23 divided by 10 is 2.3. Well, yeah, I guess it's the integer division remainder. So when I divide 23 by 10, I get 2, and then there's 3 left over. So modulus is going to give me that 3. It's not going to give me the 2 like the integer division did. It's going to give me the 3. Watch. See? So modulus gives you, here, just to prove the point, gives you a 4, see? It always gives you the remainder of a division operation. Okay? So that's what modulus does. So you have, obviously, you have the easy ones, sum, difference, subtraction, product with multiplication, division. You also have integer division. You also have exponentiation, which will be when we learn more about functions later. You'll also have the power function. And you have modulus. And modulus actually comes in handy. So we can use it, okay? So Python's going to allow us to put values in variables and then manipulate those variables or create new ones using arithmetic statements and things like that. So that's a little bit about the different kind of arithmetic we can do with Python. Let me make sure I am covering everything I want to cover with you guys. I think I am. There's only one more thing I'm going to do here. First thing I'm going to do is I'm going to teach you a trick. You see how up here Idle colored everything red because it was a comment? There's another way to do a comment, but it's not strictly a comment. if you give something 3 single quotes, and then you come down here, 1, 2, 3, and you do 3 single quotes, you see how idle colored that green? Well, it also colored the hello world green, see? When you printed it. That's because what idle does is idle makes comments red and strings green, okay? And I'll comment that like that again. It sees this as green because it sees this block as a large string. What 3 single quotes allows you to do is define a string with multiple lines, okay? But it's not, I want to say oddity, but it's not really an oddity, and it's not really a feature. Just Python, if you create a string, but you don't assign it to a variable, and you don't print it, and you don't do anything with it, it doesn't hurt anything. It's just sitting there. When you run the program, it just, it gets created, but nothing happens. You don't print it to the screen. You don't do anything, blah, blah, blah. So Python programmers will use that as a way to do multi-line comments. So a lot of time you can comment out large blocks of code by just going 3 threes, okay? So that Python programmers will use this to blot out code and do stuff. And as you'll see, I'm going to define a string. I'll just do my goofy name because I'm a simpleton. And I will do a print W because I can't just do W anymore. I'm not in the interactive window. And now when I run this code, it's only going to print Lars because all this other stuff is now seen as just a string. Now, if I go back and I get rid of these things, well, then I'm back in business and the program's running normally again, okay? But what I can do here is boom, 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 and boom, boom, boom. The reason I do this is to teach you about string literals, but I already did that with the hello world. My name is, but I'll show you how to use it with variables in the same print. So now if I say my name is with a string literal, oh my God, I couldn't say the word literal. My name is, and then comma, the variable with my name, you'll see, and prints that out. Shouldn't have done the space. My OCD will not permit that to stand. Oh, now I feel better. All right, so it prints my name is Lars because the string Lars is in the variable W, and I put the W at the end of that print function, and all is well. Okay? All right, I'm going to teach you one more thing because I'm crazy that way. Make sure you finish the block with that because you want to start. The last thing I think I'm going to do is do this. You see this program up here? I just put them back and now I'm taking them away again. I am giving you a whole lot of information about the numbers 24 and 10. Now, if I wanted to, I could change that. I can make it, I don't know, 5 and 17, and we could rerun it, and we could get new numbers for all that. So now I know the arithmetic relationships for 5 and 17, right? That can get boring pretty quick, okay? And unless I'm a programmer and I know to come in here to this file and change those values, well then if I can't do that, then it's a pretty dumb program because it just takes 2 numbers and does a whole bunch of arithmetic with it. What if, and this is what we're going to look at really fast, what if I want to run the program and give it unique variables every time the program runs? What if I want Python to ask me what I want the variable to be? That's what we're going to do. Watch. I'm going to take a variable. I'm going to call it number. And I'm going to say number is equal to, and then I use the input function. You can see it's purple. Okay? If you use a function in Python, idle makes it purple. Okay? Then I'm going to do a little prompt. I'm just going to say give me a number. Give me a number. And that's it. Okay? Oh, I don't want to do 2. So now, when this command runs, on the screen you'll see give me a number. And then if you give it a number and hit enter, well then that value will be placed in the variable number. Okay? Because I'm assigning it here to that. Alright? So now I will make up another variable. I will call it squoo. And I will say squoo is equal to number squared. You were wondering why I was calling it squoo. A little weird. And then I will say print the number is comma, I don't need that space, we just learned that, number, because it's a variable, and its square is squoo. All right, so I got a nice little 3 lines of Python there. Number equals input, give me a number. So when that runs, input's going to give me a number on the screen. I'm going to put in a number. Let's say I'm giving it 20 or 15. I usually do 20. I'll do 15 this time. So I give it 15, and then I hit enter. So now the variable number equals 15. So squoo then equals number raised to the second power, 15 by 15. What is that, 255 or whatever, or 225? So squoo equals that. So the print should come back and say the number is 15 and its square is 225. Okay, is it 225? I hope it's 220. Hold on a second. Do. So I didn't spend the whole video sounding like a crazy person. It is 225. Thank Jeebus. All right. So now I'm going to run this, and it should work, right? Right? Wrong. It's not going to work. It's going to blow up, but I'm going to show you why. Watch. Hey, give me an... Well, wait a minute. Maybe it is going to work. Maybe if I just give it 15, everything's going to... That is a Python error. Hold on. It's not very readable. Do not be frightened by Python errors, especially this one. You don't have to understand this first. When we get to the end of the course, you're going to be able to read that and know what it's talking about. But for now, don't worry about it. Something's going wrong. Why is something going wrong? Well, remember before I told you we can look at stuff with the interactive window? Let's give that a shot. I'm going to come here, and I'm going to type number. And hey, look at that. It's 15. So I entered 15, and it has 15. But that's pretty good. But there's a little trick here. Look at that 15. What's it got around it? It's got quotes around it. What does that mean? Uh-oh. Let me do this. Look at that kind of detective work. Number is a string, okay? It's a word. Python sees it as a word. So I'm trying over here to raise a word to the second power. That makes no sense. That's apples and oranges. Python is like, what are you talking about? And later on, when I turn you into computer science geek, you're going to be able to read this and say an unsupported operand type for exponentiation or the power function. Well, that's true because string, you can't do it. Okay? You need an integer or you need a floating point. So my problem resides in the input. Okay? Because input, as a default, takes whatever you give it and makes it a string. So number is a string. How do I change that? How do I tell Python, hey, what I give you, I want you to regard as a number because I want to do some arithmetic with it at the end of the day. You just do that. You do what's called wrapping the input statement in another function. In this case, the function is int. Okay? It's short for integer, as you probably already guessed. And this operation is called casting. Whenever we take a data type and turn it into another data type, in computer science, that's called casting. You can take a floating point and make it an integer. You can take an integer and make it a floating point. You can take a string and, if it's possible, make it a number. So if I take the string value 15 and I cast it to an integer, well, then Python knows, oh, okay, I want the number 15. I don't want the string 15. And then because I have a number, an integer 15, I can now raise it to the second power. And then squoo, which down here is completely undefined because we never got there, says, oh, what's squoo? What's squoo? Squoo is not defined. But now squoo will be defined because I'll have a 15 in there. It'll get raised to the second power. Squoo will equal 255. And then the number is 15, and its square is 225. Let's run it and see. See if I'm full of crap or not. Give me a number. Oh, the tension's killing me. I think it's going to work. I hope it works. Here we go. Hey, and it worked. The number is 15, and its square is 225. So now that I told the input statement that, hey, treat this as a number, then everything goes down and everything works. Okay? All right. one more thing I'm going to do, and one more thing that I usually do is, well, first, and you'll see this becomes a tradition at the end of the day. Woohoo! I run everything. Call it the grand finale. I'll give it 15 again. There's your grand finale. Woo! All the code we did during the video ran. One more thing I'm going to do. I'm going to save this. Okay? It's the end of the day. I'm tired. I'm going to bed. All right? So, goodbye. Goodbye, idle. I'm going to bed. Time to go to bed. Blah, 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 blah. Come down the next morning, and I say to myself, hey, wait a minute. I want to square the number 71. Okay? Well, how am I going to do that? Well, I'll tell you how I'm going to do it. I'm going to fire up my idle. Now, instead of having to type a whole new program in the interactive window, or instead of getting a new file and having to write everything up, the whole reason I wrote a program is because now, make this easy for me, I saved that program, and I can just go get it again. There you go. Easy. So now I can rerun it, and I'm back to where I started. And I am squaring numbers again. Oh, look. I don't want you to think I'm a fibber. I am going to square 71. And there you go. Okay? So that's the reason we write programs, is because when we write programs, we save all of our logic in a file. So that's, now that it's in a file on our hard drive, that's a durable memory store. So I can shut my machine off and go wherever and go somewhere else, boom, boom, boom. And then when I fire my laptop back up and I go and get that program and rerun it, boom, I'm back to where I was. So when I create that logic and I codify it, and it's sitting there as code, I can always use it again. And you're going to see later on in the course, we're going to create libraries for ourselves. And every time we do something, we never have to do it again. We put it in our library, and we're done. Okay? And then you're going to find out there's a million people out there doing this, and they offer their libraries to everybody else. So we can just go get a third-party library. There's a third-party library called Pygame to make video games. I grabbed that. Somebody else did a lot of the work for me. You know, I'm standing on the shoulders of giants when I make a stupid scroller or I make some kind of, space game. A lot of the hard graphic stuff is already done for me. Okay? So we're gonna get into that. I don't want to digress, but I did want to show you this. I did want to show you, hey, now that we created a program, we saved it to our hard drive. Anytime we want, we can bring it back up. We can change it. We can use it. We can do whatever we want. All right? All right. Now I think I'm going to put this one to bed. I know, and it's going to be a running joke all semester. I try to keep these short. I try to keep them like 20 minutes, 30 minutes, but blah, 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 blah. I gab a lot. So sometimes they run long. Hopefully this one isn't running long. I don't know. We did a lot today, though. I mean, if you think about it, we went to the interactive window. We looked at variables. We looked at the different kinds of data types like float and integer and strings and all of that kind of stuff. We looked at the type function to see what we're dealing with. Then we wrote a brand new program. We did a hello world program, and then we did arithmetic operations and created new variables there, and we printed them out. We learned about integer division, and we learned about modulus, and we did stuff with exponentiation without a function. We just did it with two little asterisks. And then from there, we looked at the input function. And we realized when you do input, you get a string. So if you want to do math with it, you have to use a casting operation, turn that string into an integer. If you think about it, we did a lot of stuff. I mean, hopefully in a couple of weeks, you're going to come back and look at this and you're going to go, my God, that was easy. But you know what? Right now, it's not easy. You're just seeing this for the first time. So, and that's the best thing about these YouTube videos. Watch it again. Wait a day or two and watch it again. You know, when it's time to do the homeworks, come back here. Watch the parts that you want to watch a couple times. You can watch as many times as you want. Plus, you can watch it at 2 in the morning. You can watch it in the afternoon. You can do it whenever you want. And go back and look at it. All right? It's YouTube. Go just grab this and take a screenshot. Boom, the whole program's up there. You're not going to have to do that, though, because where is it? I'm going to go into resources, and I'm going to put it in your week 1. So if you go to resources, go to resources when I click resources, please, and then hit unit 1. I'll put rev1.py in here, okay, and you'll have it. Also in here will be a link to this video, but you don't need that because you already found it because you're watching it. So never mind that part. You'll find a link to video 2 in here as well. All right, enough of that. All right, so that's it for video 1. Announcements. I'm doing this Friday night. I'm probably going to release it Saturday morning. So maybe over the weekend I will also do video 2. So hopefully by Sunday night you can have that. Then I will release the homework assignments, probably Monday or Tuesday. What I try to do, and you know this, or hopefully you know this if you've read the 101 document or you've read the syllabus, is I try to get you all of the resources you need to do the assignments with 1 week to go in the unit. That way you can do the assignments, and then the day before the quiz you can study it. As you know, quizzes are always the last day of the unit. In this case, I believe February 2nd. So your quiz will be February 2nd. Listen, don't tell anybody, all right? Quizzes are easy, so don't worry about it, all right? Don't freak out about the quizzes. We'll go over that 2 days before your quiz, I think, is our first class. So we'll go over all this stuff. Quizzes aren't bad. They're not quizzes. It's Sakai, for God's sakes. So they are basically day-long open book assignments, right? And you can, if I ask you to do something in Python, you have Python on your machine, do it. Go ahead. That's fine. That's what I like. I digress. When we get there, we'll talk about it. Other than that, keep chugging, keep going along. I know this is weird because you haven't had class yet, and you haven't talked to anybody yet, and you haven't seen anybody. All you got were these bunch of slides and the book chapter. So hopefully you got the book. If you didn't get Zell, go get Zell. I used to complain a lot about Zell, and we will go over that. But they are starting to fix things. So now I am not going to have to tell you about not using the eval statement and other things along those lines. Get the Zell. Read the Zell. I like Zell. Zell makes me crazy for other reasons, but we will discuss that at some point. But do this. Read the Zell, read the slides, and check out these videos and play around with Python. Play around with some stuff and get used to it and get going. If you cannot get Python running on your system, Sunday, Hans, who is the TA for this course, affectionately known as the Hammer, because he is a stickler when it comes to grading your assignments, the Hammer will be in the cave on Sunday. He's working. So if you go to the cave, which is in the second floor of the Hill Center Annex at the Hill Mathematical Center, that is where the instructional labs of the computer science department are. You are seeing and speaking to the manager of those instructional labs. And about 7 years ago, I built a collaborative lab called the Cave, and it acts as the unofficial headquarters of the CS undergrads. And that is where Hans will be on duty as an iLab assistant on Sunday. And if you go there and say, Hans, I'm in the Python class, can you help me with Python? He will do so. So avail yourself of Hans if you can. Other than that, I will do timely announcements. You keep chugging along. Everything's going to be cool. Next couple of days, I'll get you video too. And you will see. You can do this, and this is going to be cool. And at the end of the process, you're going to be a Python programmer. All right? Then I'm going to get out of here. I know I've probably run long, so I apologize off the bat. All right? Then you be good, and I will talk to you later. Bye-bye.